Alright guys, we're back. We're going to start chapter 5, and we're making our way into learning about quadratics. But before we get to quadratics, which is pretty much going to be the rest of the year after this, we have to first learn some basics when it comes to these different expressions we're about to see. So first and foremost, let's get some definitions down. Now I know I don't have the exact notes in front of me, but I do have a copy on my computer so I can see what I gave you guys for notes, so this should still work. Real quick, no, a nomial in math is an algebraic expression consisting of variables and numbers separated by addition and subtraction signs. The prefix will inform you how many terms you have in the expression. So again guys, we already know what terms are. Alright, an expression may have 1 term, 2 terms, 3 terms, so on and so forth. But those actually have specific names that we're going to start using. For example, a monomial. Obviously the prefix mono means 1. That means this has 1 term. It could be x squared. It could be 4xy cubed. It could be negative 56x cubed y squared z to the 7th. I'm just making things up. Those all have 1 term in them. And again, remember, it has to be separated by addition or subtraction. If it's not separated by addition or subtraction, it's 1 term. No matter how many variables, no matter how many numbers you throw in there, it's still 1 term unless you have addition or subtraction. Next one, binomial. Binomial, prefix bi, obviously you guys should know that means 2 terms. And this is going to be one of the bigger ones we see in the next couple of months because we're going to be working with a lot of binomials and factoring expressions into different binomials. So again, a binomial could be x plus 7, it could be x squared plus 49, it could be xy minus 6z. Again, 2 terms separated by an addition or subtraction sign. Okay? Trinomial. Prefix tri. That means 3 terms. And again, x squared plus 4x minus 6, xy plus 9z minus 6xz. Those are all trinomials because again, there's 3 terms separated by 2 addition or subtraction signs. And the trinomial is also going to be another big one we talk about in the next couple of months. Last one, polynomial. Poly just means many. Basically, you can call anything with more than 1 term a polynomial. So I'm just going to say more than 1. It's a very broad statement. It's a very blanket statement when you talk about any nomials. The only thing that doesn't fit in this category is monomials. So everything else can be called a polynomial. So I'll be switching in and out saying, all right, let's multiply these 2 binomials or let's multiply these polynomials. It means the same thing. So again, it could be x plus y. It could be 3x squared plus 7x minus 7z minus 6zx. I don't know. Again, that has 4, but again, it's only more than 1 terms. More than 1 terms. One thing I also want to point out, which isn't on your notes, but I do want to take note of it, is the certain number of degrees. I'm not talking about how cold it is outside. I'm talking about the degree of the expression. The degree of the expression. Again, you guys can write this anywhere you have room, but with the degrees of the expression, I'm mainly talking about the highest exponent. I'm mainly talking about the highest exponent in an expression. So for example, if we have an expression that is 3x cubed minus 2x squared plus 4x minus 6. If I want to know the degree of this expression, again, I'm not talking about Celsius or Fahrenheit, I'm talking about the highest exponent. If I look at all my exponents, 3, 2, 1, and essentially an exponent of 0 here with the variable, my highest exponent is 3. That means this is a 3rd degree expression. Also, notice how it's written. There is no law in math that says you have to go from largest exponent to smallest exponent. It's just the proper way of doing it. You don't have to, but it just makes the math flow better. So as you guys start working with these polynomials and these operations with polynomials, I'm going to suggest you guys in the end, after everything is done simplified, you guys write your answer, your expression, from highest degree to lowest degree. But again, that's a third degree. And this isn't as important to know. No one's ever going to be like, oh, what's the degree of that expression? But you may see a question on the EOC at the end of the year asking for the highest degree. Very easy question to get right, guys. Just make sure you understand that the highest degree is talking about the exponent. Okay? Now, let's get into what these notes are all about. Operations with polynomials. So it says adding and subtracting polynomials. I need to simplify g of x plus h of x minus f of x. And it tells you that f of x is 4x squared plus 2x minus 1, g of x is negative 3x plus 4, and h of x is negative 5x squared minus 1. Alright? I need to complete this expression. Now, I have to substitute. I can't just do this how it looks. I need to actually put the functions in for their notation. So g of x, I'm going to substitute with negative 3x plus 4 plus h of x. H of x is negative 5x squared minus 1. Now, we can keep this plus sign since we are adding, or we can just write minus 5x squared minus 1, because that's what h of x is. And again, since we're adding this, the signs won't change. Now the next one, minus f of x. So minus 4x squared plus 2x minus 1. Now, take a look. Do you think I did this correctly? Do you think I substituted all three of these expressions in correctly? The answer is no, I did not. Whenever you are subtracting functions, if I'm subtracting f of x, I'm not just subtracting 4x squared. I'm subtracting the entire expression. So when you guys are substituting in your expressions for these functions, make sure if you have subtraction, and that's why I gave it to you in this very first example so you guys can get used to it. When you have subtraction, you have to pay attention to the parentheses, because you're not just subtracting the first term, you're subtracting all of it. Okay? So, I have negative 3x plus 4 minus 5x squared minus 1. I'm going to distribute this negative sign through. I'm going to get negative 4x squared minus 2x plus 1. And now all this is going to be a combining like terms fiesta. Basically, you want to find every like term there is and combine it. That's all this is. Alright, the hard part about this section, if there is a hard part, is making sure you substitute them correctly. Other than that, this goes back to Math 7, just combining like terms. So I have a negative 3x, I have a negative 2x. That makes negative 5x. I have a positive 4, I have a negative 1, and a positive 1. So 4 plus negative 1 is 3, plus 1 is 4. So plus 4. And negative 5x squared, there's a squared right there. Negative 4x squared. So negative 5x squared, negative 4x squared, that's negative 9x squared. Guys, remember, in order to be like terms, I have to have everything in common. Meaning it has to be the same variable and the same exponent. That's why I cannot combine these two. X and x squared are different terms. You cannot combine them. Okay? Now, like I said, it's the proper way to write this isn't with the negative 9x squared here. It's with it in the front. So if we just use the commutative property, guys, this turns into negative 9x squared minus 5x plus 4. I'm just switching around the terms to put it from the highest degree to the lowest degree. Is this wrong? No, it's not wrong. But I can pretty much guarantee it that if you guys have a question about this type of problem, your answers, your multiple choice answer choices, will be in decreasing order of degree. So it's going to go from highest to lowest. So just get in the habit of rewriting it, and and everything should be good. Alright? Next example. So this is really the only type of application question we can work with. And for some reason, I did not include the length of the hypotenuse on this triangle. At least on my notes I didn't. So we're going to make something up. We are going to make up a length. If I want to find the perimeter of this triangle, we know this side is 8x squared plus 2. We know this side is negative 4x plus 12. Now again, on my notes I'm looking at, I don't have a length for this, but I need a length for this if I'm going to find the perimeter. So, let me refocus real quick. I'm just going to call this 3x squared plus 6x minus 2. I'm just making stuff up. So again, guys, since my notes doesn't have it on there, please make sure you include it on yours. That's my bad. But again, if I want to find the perimeter of this, I'm just going to take all three of these and add them together. That's what perimeter means. Add up the lengths of the outside. So it's going to be negative 4x plus 12 plus 8x squared plus 2 plus 3x squared plus 6x minus 2. Combine like terms, negative 4x, positive 6x, that makes a positive 2x, positive 12, positive 2, negative 2, that gives you a positive 12, and then whatever you want to do with this, 8x squared, 3x squared, that's 11x squared, and again, if I want to make this in proper form, it should be 11x squared plus 2x plus 12. So again, guys, that's really the only type of application problem you can get with multiplying polynomials, or sorry, adding polynomials and subtracting, but that's it. It's like I said, it's combining like terms fiesta. Once you actually substitute in all of your expressions, all you have to do is combine like terms. So again, make sure the important part, guys, you are including the sign when you annotate, when you circle or square or triangle your term. Make sure you are not leaving that sign out. Okay, the sign is very important. That's basically it for adding and subtracting. So again, if you guys want to hit the pause button real quick, you can try these next examples on your own. Same concepts, but if you want to go through them with me, I'm about to hit them up. So again, hit the pause button. I'm going to start. Simplify. Negative h of x minus f of x plus g of x. So I know h of x is 4x cubed minus 8x squared minus 7, but I need to take the negative of it. That means the entire quantity has to be negative. AKA, I need to switch the sign of everything. Minus f of x. Same concept. Since I'm subtracting, I need to include everything in parentheses because I'm going to negate everything. Plus g of x, which is 3x cubed plus 9. And since I'm adding, I don't need to include parentheses. I'm going to rewrite everything so the negatives are distributed through. Negative 4x cubed plus 8x squared plus 7 plus 3x squared minus 2x minus 1 plus 3x cubed plus 9. I get it, guys. It's getting very tedious, very monotonous, over and over again, the same process. But again, it's an easy concept. It's just very, very error prone if you mess up the signs. So make sure you guys are paying extra attention to what sign you have in your multiplication. Alright, I'm going to use lines to denote which ones I'm combining. So I'm going to combine negative 4x cubed with 3x cubed, which gives me negative 1x cubed. 8x squared, 3x squared. I'm going to underline the sign with it. That gives me 11x squared, 7, negative 1, 9, 7, negative 1, that's 6, plus 9, 15. And there's nothing for the negative 2x, so it's just negative 2x. If I rewrite this so it's decreasing order, it's going to be negative 1x cubed plus 11x squared minus 2x plus 15. Last one, it says simplify. We're going to use the same functions to simplify this down. So for number 2, it's going to be g of x, which is 3x cubed plus 9. It's going to be negative 2 times f of x. So I'm going to actually not distribute a negative sign through f of x. I'm going to distribute a negative 2 through f of x. Again, that just means we're multiplying the entire function by negative 2. And plus 3h of x, same concept. I'm going to distribute the 3 through everything in h of x. I get it. Very tedious, but you get the picture. So I'm going to go quickly, and hopefully I'm not going to make a mistake. That's plus 6x squared minus 4x plus 2 plus 12x cubed minus 24x squared plus, minus 21. Yeah, minus 21. Okay, 3x cubed, 12x cubed, that's 15x cubed. Positive 9, positive 2, that's 11. Negative 21, that's negative 10. I'm running out of shapes. Positive 6x squared, negative 24x squared, that's negative 18x squared, and there's nothing else for the 4x, so it's minus 4x. If I put this in decreasing order, it should be 15x cubed minus 18x squared minus 4x minus 10. Minus 10. And that's it, guys. That's adding and subtracting polynomials. Again, it's annoying. As you can see, all these numbers, it's very, very easy to make a mistake and not even realize you made a mistake. So, be extra careful. Don't rush, because these easy questions need to be mastered. You guys need these points when it comes to the EOC. Okay? So, flip to the back. And we're going to probably do one of the most annoying things you're going to come across in Math 1. And it's a very basic concept that you're just going to start learning that you will use until you graduate high school. So the next concept that I'm about to teach you is something that you are going to have to do from Math 1 all the way up through calculus. Okay? So let's start. Section 2. Multiplying polynomials. So we just dealt with adding and subtracting. Now we have to go through multiplying polynomials. The big thing that I will teach you, there's 2 ways to do this. The first way, I mean, it's the same way. They're called 2 different things. I'm going to teach it to you as distribution, because that's the mathematically correct way of doing this. We are just distributing over and over and over and over and over again. That's all we're going to be doing. There's also another acronym that's used. I'm not even going to tell you the acronym because I despise it with my entire body and soul. I hate it. So instead of just telling you it, we're just going to call it distribution, because that's what it essentially is. So let's take a look. When we distribute, we only typically distribute one term through the set of parentheses. This time around, we're going to distribute everything that needs to be distributed in the set of parentheses. If you're confused, you'll see what happens in the second half of this. But for now, we're just going to multiply monomials through polynomials. So basically, we have one term on the outside, which is negative x cubed, and we're going to multiply that term to everything on the inside. This is also why it's pretty important, guys, to master your laws of exponents. Because if you're not good with your laws of exponents, you are going to get these wrong left and right. So again, if you still don't remember your laws of exponents, please go back and refresh yourself. Look at your notes. Look at something to give yourself a reminder on how to do this. But again, same concept as if I was distributing a number. This time I'm just distributing a sign, a negative, sorry, not a sign, a variable, with a negative with it. So it's negative x cubed. So again, negative x cubed times 9x squared, sorry, x to the 4th. It's going to be negative 9 I know that because negative 1 times 9 is negative 9. Now remember, ask yourself, what do I do when I multiply like bases? If I have x cubed times x to the 4th, what do I do when I multiply these? Do I multiply the exponents or do I add them? The correct answer is you add them. Negative x cubed times negative 2x cubed, that's going to be a positive 2. X cubed times x cubed is x to the, not 9, 6. Add the exponents. And finally, this one's easy, minus 7x cubed. Boom. That's multiplying polynomials together. Second example. Negative 3x squared times 2x cubed plus 4x squared minus 6. Same concept. I'm going to take this entire term and multiply it to everything in here. So again, we're basically just redoing our exponent laws. So negative 3 times 2 is negative 6. X squared times x cubed is x to the, not 6th, 5th. Negative 3 times positive 4 is negative 12. X squared times x squared, I mean, you're safe with that one. 2 times 2 is 4 and 2 plus 2 is 4, so it's x to the 4th. But remember, you add the exponents. Last one's easy, plus 18x squared. So, that's it. That's all we're doing. You guys can hit the pause button now. You guys can try these next two on your own. I'm going to fly through it. I'm not sure if you can hear a squeaking in the background, but that's my washing machine. So if you're wondering what that noise is, that's what it is. If you don't hear it, never mind what I just said. Alright, moving on. Number 1. Simplify. 5x to the 4th times negative 3x cubed minus 4x plus 2. Again, I'm going to take this entire term and multiply it to everything. So it's going to be negative, well, 5 times negative 3 is negative 15. X to the 4th times x cubed. What is it? Is it x to the 12th or is it x to the 7th? It's x to the 7th. Wow, I almost just kidding myself. 5 times negative 4 is negative 20. X to the 4th times x to the, remember guys, there's still an exponent of 1 there. That's going to be x to the 5th. And next, last one's easy. Constant times the term is just 10x to the 4th. Second example. Negative x times negative 3x to the 4th minus 4x cubed plus 2x. Again, I'm going to multiply everything by this negative x. I'm going to distribute it to everything. Negative times negative 3, so negative 1 times negative 3 is positive 3. X times x to the 4th is x to the 5th. Remember, that's an exponent of 1 there. Negative 1 times negative 4 is positive 4, x to the 4th. And negative 1 times 2 is negative 2, x squared. Again, multiplying monomials to polynomials is easy. It's not that difficult. It's pretty straightforward because we kind of already did this when we did our laws of exponents. You guys were multiplying variables together the entire time. We're just revisiting it. It's this next concept that is new. And this is the concept that you guys are going to have to be doing from now until calculus. So, what happens when we don't have one term? What happens when we have to multiply two terms? 2x plus 4 times 3x minus 2. So, previously, we multiplied the term on the outside to the terms on the inside. We no longer have one term on the outside. We have two terms on the outside. So, same concept, we're still distributing. But we're not just distributing the 4, we're also going to distribute the 2x. So we're going to distribute everything in this set of parentheses into the second set of parentheses. So for example, I'm going to take this 2x, I'm going to multiply it. 2 times 3 is 6. I'm going to actually write it down here. X times x is x squared. 2 times negative 2, that's negative 4x. That's what you get when you multiply the first term through. I'm not done though. I still have to multiply the second term through. So 4 times 3 is 12. And 4 times negative 2 is negative 8. Now, again, whenever you have polynomials times polynomials, you have to distribute you have to distribute every single term on the inside of this set of parentheses to this set of parentheses. If I had 5 terms in here, I'd distribute 5 different times. If I had 17 terms in here, I'd have to distribute 17 different times. But since I only have 2 terms in here, I only distribute twice. Now, do you think I'm done? Do you think this is my final answer? I'm not done. Because if you guys saw, negative 4x and 12x can be combined. This actually turns into 6x squared plus 8x minus 8. You are not done until you combine like terms. Once you simplify it down to the most compact expression you can, then you're finally done. Second example. It's an application problem. Again, guys, if you're going to see any type of application problem with this concept, it's going to be in the terms of finding area. So it says find the area of that triangle. We know the area of a triangle is area equals 1/2 base times the height. So 1/2 times 2x plus 8. I'm going to include that in parentheses, times 3x squared plus x plus 12. Now, here's how multiplication works. I do not have to distribute this to everything. I'm not going to take the 1/2 and multiply it to all 5 terms. I only have to multiply it to the most immediate set of parentheses next to it, meaning I can multiply it to here. Or I can choose to multiply it to here. I'm not going to multiply it to both. I could also multiply it at the end. But if I take a look, guys, 1/2 times 2 and 1/2 times 8, those are actually nice numbers. So I'm going to distribute this. That's going to be now x plus 4 times 3x squared plus x plus 12. Same concept. I'm going to take this term, boom, boom, boom. X times 3x squared is 3x, again I'm going to move it down here, 3x cubed. X times x is not 2x, x squared. X times 12 is 12x. Next one, 4 times 3, that's 12. 4 times x, that's 4x. 4 times 12, that's 48. And again, I'm not done. I still have to combine like terms. There's no other cubed, 3x cubed. If I look for my x squared terms, x squared, 12x squared, that's going to be 13x squared. If I look for my x's, 12, I'm going to actually square them, 16x. And there's no other constant, 48. And again, I'm still not done. Actually, I lied. I am done. 3x cubed plus 13x squared plus 16x plus 48. That is your simplified version. Again, guys, I don't know why I actually just skipped to that one. I just realized that's the last example. Whatever. Doesn't matter. But you get the idea. Okay? So my bad. I'm going to go back to the next example, the second example. This was actually the 4th example. So if you were wondering the entire time, Mr. Z, why did you skip 2 questions? I was clearly not paying attention to my set of notes. So, (3x minus 9 squared). Let me refocus it, and let me tell you something. This does not, notice how big this not equal sign is, because I need to make this clear. This does not equal 9x squared minus 81. It does not. It does not, it does not, it does not. We do not distribute this through. Okay? We don't. And you're probably wondering, Mr. Z, when we did laws of exponents, we distributed that exponent sign to everything on the inside of the set of the parentheses. I agree, we did. But if you go back to all of our notes, everything we worked on, the set of parentheses never, ever, ever had an addition or subtraction sign in it. When you have an addition or subtraction sign, you cannot bring this through. Now, ask yourself, what does squaring actually mean? Squaring means you multiply it by itself. That's what we have to do here. 3x minus 9 squared really means 3x minus 9 times 3x minus 9. Again, guys, this is an important concept to understand. Whenever you have a binomial or a trinomial or a polynomial squared, you have to multiply it by itself. So, going back to our distribution, the first number has to get distributed through. 3x times 3x is 9x squared. Oh, Mr. Z, that's what we got up here. Yeah, I know we did. Okay, but it still is not going to work out. Watch. 3x times negative 9 is negative 27x. Negative 9 times 3x is negative 27x. And negative 9 times negative 9 is a positive 81. If I combine like terms, 9x squared, negative 27x, negative 27x is negative 54x, and positive 81. Now, this is called the difference of sums, I think. I think that's what it's called. Regardless, that's how you do it. If you notice, though, some numbers should pop out to you. 9x squared is 3x squared. 81 is negative 9 times negative 9. This negative 54x, guys, this actually comes from negative 9 times 3 times 2. So there is a pattern here when you multiply this through. When you guys get comfortable enough, I'll reintroduce this topic to you so you can start finding shortcuts to do the math quicker. For now, don't worry about it, but just remember there is a pattern when you have to square out binomials. But again, multiply the first term through, multiply the second term through, combine like terms, and we're good. Next example. Negative 4x plus 9 times 3x squared minus 2x minus 1. Oh, Mr. Z, oh my God, this is so difficult. It's a binomial times a trinomial. I get it, guys. I get it. It's still the same concept. You take the first term and multiply it to everything in the set of parentheses. It doesn't change. So, negative 4x times 3x squared is negative 12. X times x squared is x cubed. Negative 4x times negative 2x. Negative 4 times negative 2 is a positive 8. X times x is x squared. Negative 4x times negative 1 is a positive 4x. Same concept. Boom, boom, boom. 9 times 3 is 27. 9 times negative 2 is negative 18. X. And 9 times negative 1 is negative 9. Finally, combine like terms. There is no other x cubed term. And typically, guys, I mean, you're not going to have a matching first term for the most part unless things happen. But typically, this is how it works. Okay, so typically the first term will never have a matching pair. Let's go with x squared. I'm going to square the squared because it makes sense to square a squared. 27 and 8 is 35. 4x, negative 18x is a negative 14x. Negative 9 is all by itself. And that is how you multiply those out. Again, guys, once you get the hang of this new concept, it's not difficult, it's just annoying. It's very easy to make a mistake. So when you guys are working through these, please be careful when you do this. Go slow. Make sure you double check your multiplication. Make sure you check your exponents as well. It's very easy to make an exponent mistake with these questions. So you can hit the pause button. We went through all 4 examples, kind of out of order, but whatever. Hit the pause button. I'm going to go through these next 2 examples fairly quickly because it's 4:30. It's almost time for the Super Bowl, and I need to start getting ready to go watch that. So simplify these next 2 examples. The first one is negative 5x minus 4 times 8x plus 1. Negative 5x times 8x is negative 40x squared. Negative 5x times 1 is negative 5x. Negative 4 times 8 is negative 32x. Negative 4 times 1 is negative 4. Combining like terms, negative 40x squared minus 37x minus 4. That's the next example. Last one, guys. 6x plus 5 times negative 3x cubed plus 2x squared plus 6. If I'm going to multiply this, 6 times negative 3 is negative 18x to the 4th. 6x times 2x squared is 12x cubed. 6x times 6 is 36x. 5 times negative 3x cubed is negative 15x cubed. 5 times 2x squared is 10x squared. 5 times 6 is 30. Combine like terms. There's no other term to the 4th power. Cubes. I'm not going to draw a cube. I'm just going to circle it. 12x cubed, negative 15x cubed. That's negative 3x cubed. Squared. Only this one is left. I don't know why I circled it. I'm going to square it. Why didn't you guys tell me you couldn't see it? Why did you not tell me you could not see what I was doing? Come on now, guys. Depend on you for so much, and you can't even come through. Can't even come through. Plus 36x plus 30. Sorry if you missed some of that because I clearly was not paying attention to my screen. But that's the simplified version. Again, 1, 2, 3, 5 terms. 5 terms. That's the notes, guys. With this concept, it's very, very important to practice over and over again. This is not a conceptual understanding. It's more procedural. Okay? Meaning just practice the procedure of distributing through over and over again, and you should be able to master this topic. It's a very easy topic to practice on Khan Academy because of just the procedural notion of repeating it over and over and over again. So that's it. Those are the notes for today. Hopefully you guys got through everything because the next set of notes we are going to actually reverse this operation that we did today. So instead of multiplying numbers through, you're going to see how we're going to be dividing numbers out tomorrow, also known as factoring. So again, make sure you guys got this. Make sure you subscribe to my channel when I update with new videos on the daily, and by daily I mean whenever I feel like it, and when I mean it's whatever. Otherwise, hope you guys watch the Super Bowl. Let's go to Philadelphia because let's be honest, no one likes New England. Peace.